Anyway, so let's talk about unit system in LSI. Why this is important? Okay, so we talked about node element FEM. We are going to continuously discuss on finite element methods, so don't worry about it. Every day there will be some or the other discussion about FEM. So I'm not just going to push through what is FEM in a classical manner of stiffness matrix, shape function, and other bit. That will come, but with a context. Some relation will be there. That's something which I want to do. Okay. I think. Okay. So first thing first, let's talk about SI units. I'm going to give you an exercise here, but let me just generate a table first of all. So let's say this is SI. This is material. E value, density. Okay, let me switch on my laptop camera. It will be a little weak, but still it will work. Yeah. Okay, little weird angle, but just bear with me. Then we have. So we'll go for, let's say, okay, let's do it other way. This will be second table. For SI system, we'll go for mass unit. We'll go for length unit. We'll go for time unit. And these three units will be independent units. Is that fine? So these three will be independent units. The next is we are going to go forward with dependent units. Let's say stress, or first we'll go by density. Then we'll go by stress or force, first of all, force, and then we'll go by stress. Okay, so for SI, we have mass, length, time, density, force, and stress. So if I just replace this SI here, I think this will be better. Yeah, looks fine. Mass in SI system, what it will be? Kilogram. Okay, not kg. Kg is what we write down. Kilogram is what we talk. Okay, so we are going to talk kilograms. It's a weird angle. So yeah, this is better. Yes. So we have kilogram as our unit for mass. For length, it is going to be meter. For time, it is going to be seconds. For density, it is going to be kilogram per meter cube. For force, it is going to be Newton. And for stress, it is going to be Newton per meter square, which is what? Pascal. Am I right? Yes or no? Type in yes if this is correct. Okay. Now I'm going to give you an exercise. I want you guys to go on internet and check for any truck brochure. So go for a truck. Truck is a very large automotive segment. So go for a truck website, Ashok Leyland, Tata Motors, or Bharat Benz, or anywhere, and try and download a brochure. I will allow you to share screens and just let me know in what unit you get the length of a truck. Let's see. In what unit you are going to get length of a truck. You can answer in chat box or unmute and talk, not a problem. And we can have a share screen option as well. So you can share screens as well. What it is? It's in millimeter. Can you share your screen, Niranjan or Sandeep?
Yes, sir.
I have enabled screen sharing, so I'll just stop sharing 1 second. Yeah, there you go.
Okay. I have shared, sir.
Okay, so wheelbase is in millimeter, right?
Yes, sir.
Sandeep says it is also in millimeter. So now you can also go on a website for PDF. So let me just show you how detailed it is. So this was just an information from a third-party website. But if you go for, you guys are able to see my screen, right? So
should I stop sharing?
1 second, 1 second. I'll stop sharing first. Yeah. Yeah, Niranjan, yes, please stop sharing. Yes.
Yes.
Okay, so if I'm sharing my full screen, I'll just show you. If you go for Tata LPT3118, okay, for example. By the way, do you know what is the significance of this 3118 or 1216? Just a general question. Okay, so this is a cowl and Signa chassis. So there are two different things. If I go for, I'm going for Tata trucks. Okay, I'm going on Tata website directly. And I'll just go for a PDF here. And I'll just show you the specifications are there. And I can download it. I think the download option has to be there. Okay, if I go for, okay, 1 second. So if I go for PDF brochure, yeah, there you go. Yes, this looks better. So this is already a PDF. Yeah, this is so I can save this. Now, if you can scroll down, or if you can just see this part. Oops, it's not having much of an information here. Yeah, here you go. Yes. Okay. So overall length 9635 millimeter, 9890 millimeter. Okay. So we have a very favorite unit in industry, which is millimeter for sure. So we are going to talk about LSDYNA unit system 1. Length will be in millimeter. Okay. Time industry uses as second as well as millisecond. So we are going to come to millisecond in LSDYNA unit system 2. Okay. Now I want you guys to go to any steel manufacturer website, ArcelorMittal, Tata Steel, Nippon, or POSCO, and just search for this material, DP590 or SC430. I'll stop sharing, and I want you to find out in what unit you have the stress values. Okay, in what unit you have the stress values. So do you have, Sandeep, do you have anything to share? Your answer is correct, but do you have anything where you can say that this is in MPa, like the data sheet which I showed you right now?
Yes, sir.
Just share your screen. Yep. Okay. So in ArcelorMittal website, you have DP590, DP450, dual phase. It's a dual phase material. And you can see tensile strength in megapascal. Yield stress in megapascal. Am I right? So what is happening, guys? Whenever we have our stress unit in Newton per millimeter square, we call it as megapascal. Am I right? It is Newton per millimeter square. That is what is megapascal. So let me share my screen again. Here you go. So if you have your stress in Newton per millimeter square, which is obvious. So that means you need your force to be in Newton. Density needs to be found out and mass needs to be found out. To achieve, okay, so to achieve stress to be in Newton per millimeter square, what should be the mass? That's the question. Okay, if your length and time unit is given. This is question for you for the rest of the day. So you have to solve it today and send me the answer. You have to solve it today. It's not going to be tomorrow. And similarly, there is another unit system which is preferred by crash analysts and OEMs, because crash time is measured in milliseconds and vehicle mass is measured in kilogram, right? What you saw. So if your vehicle mass is in kilogram, length is in millimeter, time is in millisecond, you will get the density. What will be the force value and what will be the stress value? Is that making sense? So I'll just circle what is it that you want to find out. Okay, that's the exercise which you are going to do today. Okay, after the session. So this is extremely important because LSDYNA understands no unit system. Remember this. LSDYNA understands no unit system. LSDYNA only understands consistency in unit system. Okay, so I'll write down this sentence. LSDYNA understands no unit system. It only understands consistency in unit system. So there is no unit system specified by LSDYNA. You can tailor make your own unit system, but you have to be consistent. That means if I'm giving mass in kilogram, length in meter, time in second, I'm getting my force in Newton. What if I give my mass in some value, length in millimeter, and time in second? I should be still getting my force in Newton. Okay, that's the question. The next question will be, if my mass is in kilogram, length is in millimeter, time is in millisecond, what will be the force value, which is a consistent force value for the given input, and what will be the consistent stress value for the given system? Is that making sense, guys? This is going to be the base, what you can say, stronger base of the overall understanding of LSDYNA. Okay, can you do this? You will be able to do this today, right? And we are going to talk about many different things. I'm going to add 2 more sessions for your week to move forward. I want you to first focus on LS pre-post. So for rest of the week, you please focus on LS pre-post and make sure you solve this problem. Take a screenshot on your notebook, whatever you are working on. If you are facing a difficulty, let me know on group. The group is not just for sending you a message that I am online. The group is to make sure you are learning continuously every day. Okay, clear? Can you draw this table? Can you create this table by your own? and solve it and send it to me today itself before you go to sleep. All right. Okay, so I have already shared this presentation with you. I'm saving this. You will be getting a direct access to it. We will give it a try. Okay, so I'm going to close this presentation. You can open WhatsApp web at your on your computer and try to open this presentation. The link